beautiful people, and welcome. In this video we will be discussing lateral area. Now you need to know lateral area before you go to solving surface area. So we're going to spend a little time talking about lateral area in this video, and then you'll be good to go for surface area. Disclaimer time, as always, I am a human. If I make a mistake, let me know where the mistake occurs so that way I can fix my mistake, learn from my mistake, and that way you don't have to make the same mistake. All right. So lateral area is indicated by a capital letter L. Now in my class, I will throw in an A, so my abbreviation for lateral area will be LA. But in notes in your cheat sheets, it would be noted as capital L. Now that matters, capital and non-cursive. So let's start out with the cylinder. Here we have a cylinder. And for a cylinder, it is super important to know how it will look like when you uncut it. So what I mean is, here's a cylinder right here. I have a cylinder. If I was to open this up, how will it look like? Now, I do have some scissors right here. I am cutting this little shape open for you. All right, so here is the top of it. And I know you can't see me cutting, but that's okay. Here's the top of it. Here's the bottom. In like 10 seconds. I hope it doesn't take me 10 seconds to get this cut open, but you never know. And yes, of course, I could just draw it, but hey, why not? If I can play around with scissors, I will. Not to say that I'm encouraging you playing around with scissors. Don't play with scissors, children. There you go. I just had to rip it. All right, so we have the top, we have the bottom, so we have two base. So this base is the top, this base is the bottom. And then what we have left over is the lateral area. Okay, so lateral area is the area excluding your base. So that's why if you have not watched the nets video, go ahead and watch that. Or what I highly recommend is actually go to YouTube and watch the nets video of someone who has done it on like a program, like a graphing program. It'd be easier to understand what nets are. So a net is us unrolling, ungluing, taking each section of our 3D picture and identifying what we have. So I have a top, I have a base, I have a bottom base, and then this right here is what is left over. So it was rolled up with the base on top and the base on the bottom. So I have created a net by splitting it open, and this is what we have. So this is a base, and I keep saying that these two are bases, super important. This right here is what we want for our lateral area. Well, what shape is it? Now, before you say, it's a rectangle, hold up. Okay, hold up. You're kind of right and you're kind of wrong. Sure, it looks like a rectangle, absolutely. So if we had a rectangle, this would be what? Our length and our width of our rectangle. So that's fine. So if we had that rectangle, let's draw this out. So I have my base, and this is how it looked. So I have it rolled up, and I have it unrolled. So this right here, this section from top and bottom, what would that be? So let's throw in some units of measure and then make sure that we can identify what we have. So let's make this 3 meters, and let's make this diameter, let's not. Let's make this the radius of 1. Let's just do basic numbers. So we have a height of 3 and a radius of 1. So again, if we had our cylinder, here's our cylinder, here's the top of it, ooh, that's the bottom of it. We got a giggle out of that, that was kind of funny. This, from the one side of the base all the way down to the bottom, perpendicular to the base, is our height. So when we unroll this out, top, this is where our base used to be, and this is where the other base used to be. This right here is our original height. So if our height was 3, this side of our quote-unquote rectangle would be 3. Now again, when you said rectangle, I said, hold on, not quite. So this is our height. So let's go back to our cylinder. Again, let's hope that doesn't. And put our base on top. So what is the shape of the base? A circle. And how does this edge act around the circle? And around is a key word. This edge right here, actually that worked out, it kind of stuck together, is going around the circle, around the edge of the circle and kind of hugging it all the way around. So what is it called when you go around the circle? And I know this is not perfect, but when you go around the circle, all of it, what is that? Well, let's talk about the circle. We know that the radius is from the middle of the circle to any point on the circle. We know that the diameter is from one point on the circle to the opposite point of that circle. So we have the radius, we have a diameter, and then what is the last part of knowing of circles? We know radius, diameter, those are the most ones. I mean, pi, 3.14, right? Don't do it. Pi is not 3.14. And so the other part is if we start on one edge and we walk all the way around, keep going around, that distance is called the circumference. Sorry, it's kind of small. I'm trying to squeeze it into my paper. That is called the circumference. So when this was the height of the cylinder, this part right here is actually the circumference. So then it's kind of like, well, what's the circumference of a circle? So we talked about the circumference. So what is the circumference of a circle? The circumference of a circle is 2 pi r. Or you can say, I believe it's 2 times the, no, I'm going to take it back. I won't even finish it. 2 pi r. So if this was our height, then this section from here all the way to here is our circumference because, again, originally we completely hugged the circle with that edge. So now that we have unglued it, this edge used to hug that circle, and this edge used to be the circumference of that circle. So we have 2 pi r. So now we know that this is our height. We know that this is our circumference. And so what is the lateral area? This is our base. I'm going to write lowercase b because we're not doing the areas of it yet. So this is our base. This is our base. So for lateral area, we want the area without the bases. Let's actually write that down. So lateral area is the area without the base. And I'm going to put base and then this S in parentheses because sometimes you will have 2 bases, sometimes you will have 1 base. So if this one, for example, has 2 bases, something like a pyramid will only have 1. All right, let's actually calculate this lateral area. So lateral area of our cylinder would be, let me draw this out again. Our height is 3. This section right here is 2 pi r. 2 pi, what is our radius? Our radius is 1. So I have 2 pi times 3. So I have 6 pi. So our lateral area for our cylinder is just 6 pi. Now I did not give you units. Oh, I gave you 1 unit. So it would just be meters. Now, here's what's super duper duper important. Volume is cubed. Area is squared. Volume is cubed, area is squared. So when we were watching videos about, hey, what have we been doing? And we would ask the questions, what do we want? We're wanting volume. Volume means the answer is cubed. Now we're asking, what do we have? We have area. Area is always squared. All right, let's do one more example for the, let's try a different one. And again, this is just an introductory to lateral area. We'll do more examples when we talk about each individual 3D figure, like if we do a cone, if we do a pyramid, we'll do an example on each. This is just an introductory video. So let's do one more example. So example 2. Let's do a triangular prism. So here we have a right triangular prism. And what that means is that the triangles that we have are right triangles. Now I do have a triangle here. It is not a right triangle, as you can see, but it kind of gives you an idea of how things look. Before I move on too quickly, let's go ahead and give you units of measure. Here I have 12 centimeters, this is 6 centimeters, and this is 8 centimeters. So again, our question, what we want, our prompt is calculate the lateral area. Again, lateral area is the area without the base. So we don't want the base. What do we really want? If we were to undo this, and again, let's cut this open just because. Now, if you're watching this video, I want you to take this time to draw out the net of this triangular prism, because either way, we're going to have to draw it out. I just want to show you how this would look if you were in my class. And if you were in my class, then we would play around with these, get some scissors involved. And if we're lucky, maybe some coloring pencils, markers, but unfortunately, you are watching a video. If you have that in front of you, if you want to play around with it, go for it. You can create your own. I'm almost done with this. Give me just a few more seconds. All right, here is our net. Ooh. Too much glue, not enough scissors. Okay, here's our net. And again, this is not a right triangle. This is a right triangle, but that's kind of how it looks like. So notice, we want the area without the base. So without the base, we have these 1, 2, and 3 rectangles. Okay, so what is the area of the base? 1, 2, 3 rectangles. Now let's draw this out. So here is my triangle, and here's the right angle. Here's another triangle. Again, these are right triangles. Now these look a little bit more pointy, that's okay. I put that little symbol knowing that those are right triangles. So again, imagine you had a triangle just like this. Actually, it would be this way, just like this. And then we opened it up this way. So what do we have? On this edge here, what was it? It was 12. And then this here, what did this side cover? Well, it covered this right here. It covered this side of the triangle. This side, the middle part, covered this part of the triangle, and then this last part covered the outside. The 3 sides of the triangle. So 1, 2, 3. So there's 3 sides of the triangle. This length right here was 6. This length right here was I'm trying to see. If we are holding the triangle this way, so this is 6, this is 8, and we don't know what the back side is. Ultimately, it doesn't matter because I'll show you what we're going to do. So you just want the 3 sides of the triangle. And what we really want is the perimeter right here. We want the perimeter of the base. That's why I said it doesn't really matter like where you put the 8 or the 6. So this side is going to be the perimeter of the base. It was also the perimeter of the base here, except because our base is a circle, the perimeter of a circle is the circumference. So we want the perimeter of the base. So how do we find that out? Let's look at that base because we want this section right here. That's what's missing is this section right here. Good thing they gave us a right triangle. I know that I have a 6, I have an 8, so I wonder what this is. Again, good thing they give us a right triangle because we can use the Pythagorean Theorem. Let's do that quickly. 8 squared plus 36 squared equals c squared. This is 64. Just kidding. Did you see what I did there? My mind is working a little faster than I am today. 36 is equal to c squared, so I have 100 c squared, so c is equal to 10. Again, anytime you take the square root, it will always be plus or minus. However, we are talking about distance. Distance cannot be negative, so we just have 10. So we write 10 up here. So what is the perimeter of the base? Sorry about that, you guys. I don't know if you saw there was a glitch in the video, and that's because my phone went off and I needed to take that. All right, you guys, I wanted to clarify something here when I say perimeter of the base. So I'm going to erase that. So calculating lateral area is we want the perimeter times the height. So perimeter of the base, let's do this lowercase because capital B represents the area. So we want the perimeter of the base times the height of the prism. So this right here is the perimeter of the base. This is the perimeter, and this is the perimeter of it, okay? So now that we have the perimeter here of the base of the original triangle, we don't want the perimeter of the inside. We only want the perimeter of the base. That's what I wanted to clarify. So let's count these out. I have 10 plus 8 plus 6. That is 24. So I have 24 times 12. And that is lateral area is equal to 288 units of measure centimeters. What are we trying to find? Area. Area is always squared. And I apologize about that. Let's do this one here. We want the perimeter of the base. Here's the base. Here's the perimeter, the outside of it. And this perimeter of the base matches to one of the sides of the insides because we only need one inside and the height. And then the height of the cylinder, prism, whatever we're doing is here, and that's here. And let me color code this for this example because I just want to make sure that I made it. So here's the height of the prism. Here's the height of the prism. And we need the perimeter of the base. Perimeter of the base. The base of the original 3D figure that they give us, not the rectangle that you see. We don't want the perimeter of the rectangle. Unless you have a rectangular prism, then that's different. All right, beautiful people, that's it. I'm going to wrap it up. Again, this is an introductory video for lateral area. We will continue doing more lateral area in surface area because you're pretty much there. If you know the lateral area, then you should be able to calculate surface area. If I made a mistake, I apologize. Thank you so much for watching my video. As always, thank you and have a great day. Bye.